All right, in order for us to do the next construction, I need to review something that you learned in pre-algebra. We're about to create a line parallel to a line that's already been given through a specific or given point that's not on the line. So real quickly, I just want to review with you something that you would have learned in pre-algebra, but you may have forgotten about in the intervening time. If you have two parallel lines and they are cut by a transversal, your corresponding angles are congruent. And by corresponding, I mean this angle and this angle, for example. In other words, if these were two street intersections, this would be the northeast corner of the intersection, and this would also be the northeast corner of the intersection. So these two are corresponding angles, and they are the same size. In this construction, you are going to start with this line here and this point right here. And essentially what you are going to do is you're going to draw this transversal, and then you're going to copy this angle up here, which is going to give you this line, and it's going to force those two lines to be parallel, because if these two angles are congruent, then the lines are parallel. All right, so let's take a look at what this would have looked like without a ruler, without a protractor, just a straight edge, compass, and pencil. So I'm going to take my straight edge here, and I am going to draw a nice long ray. Okay? And this end here is going to be, well, actually, I don't care. I don't need an end. It's a nice long line. My bad. I'm going to make a nice long line. I want to make a parallel line that goes through this point here, P. So I want a parallel line to this line that goes through that point right there. So the first thing I'm going to do is I'm going to draw the transversal that will eventually cut both parallel lines. Now for this transversal, I do not want to make right angles. I also don't want to make an obtuse angle. That makes it much more difficult. I want to put it about like that and just have a gentle, acute angle, okay? And I'm going to just draw that line like so, okay? So this would be the transversal eventually. I'm going to call this point of intersection X. Now, I need to take my compass, and I don't want to make it too small. If it's too small, this really gets very hard to make. So I'm going to do something like this. I think that'll be a good size to work with. And very securely having my compass lid, I want to have my compass here at that intersection point where X is, and I'm going to make a mark. In fact, I'm just going to make an arc all the way up until it hits that line. So I need an arc that hits both sides of that angle. Do not change the setting on your compass. Pick it up, put it here, and do the same thing again up here. Okay, same thing again up here. All right. Now, you are going to take your compass and you're going to measure from this point to this point. And we don't want the arc here. We don't want the curved line. We want the straight distance. So we're going to put one end, the sharp end on one side, and oh, it just happens to work out perfectly. And then the pencil end on the other side. Now mine just happened to be the same size. Usually you have to change your setting some, and it needs to be exact. Okay, you have to have the right distance here. Okay, so now I'm going to pick this up, and I'm going to bring it all the way up to where the arc crossed. Because remember, it was here where this arc crossed the ray down to there. So I'm going to bring this up all the way to where this arc crosses the ray. And then I'm going to make a mark here. Okay, I've just measured that same distance, right? And now what I need to do is line those points up. I can't see. No, I hope these turn out parallel. I can't really see what I'm doing. And then I'm going to send the line across. Oh, and looky there. They're parallel lines. And if you really want to check it, you can get out your, your protractor and check it. But the ancient Greek mathematicians, they didn't have a way to measure the angles. So they had to use relationships, postulates, and theorems that would say, okay, if these lines are parallel, then these two angles are the same. And I hope that you noticed that they were also using this to measure distances, okay? Although you can create curves and arcs, you can also set this to measure a distance, all right? And that's what they used. This is how they measured things. They measured things relative to each other. They didn't have a measuring system like we do with like meters or centimeters or inches or those sorts of things. Their measurements were always relative to other objects. So you have just created a parallel line through that point by copying over the congruent corresponding angles.